Okay, so let's go over the answers here in 2016 multiple choice mod 2. So looking at question 1, we have graph of relation. Clearly it's not a function because it does not pass the vertical line test, and that's what they're asking here. Just which statement about the relation is true. Go through, read all of them, and cross them off as you know that they are incorrect. Narrow them down. If you narrow them down to 2, then there's usually one word in there that makes it so that it's not false. But in this case here, it's pretty obvious that the answer is going to be D. Question 2, remember for relations, when we're talking about domain and range, one of our things we can remember is that Dixie, Royd, and remember Dixie, I'll put the Royd in there too, Dixie, the D stands for domain, and the I is the input, X is the x-axis, and I is the independent. So going through here, we see that the domain is made up of the numbers of 2, 5, and 14. So that's what that question is asking there. Question 3, they give you a lot of information. They tell you how many miles are on Denny's car, meaning that's what his odometer is reading, and they tell you that he's driving 55 miles per hour, and going through and reading through it, and you realize that when you look at his graph is a little bit harder to read. So I also was remembering that, well, if it's 55 miles per hour, that means in 2 hours it's 110 miles. So going through and seeing that he has that 14,000 miles to start with, that eliminated B very quickly. And A, C, and D are right there. And then I know it every 2 hours is going to be 110 miles. So when I looked at A, I went over it 2 hours and traced up, and that gave me about 110 miles more than the 14,000. When I went over 2 hours here, I can see that I'm at about 14.5, which is more than what I wanted to be at if I'm at 14,000 to start with. So that's how I eliminated C. And then on D, again, I'm at 14,000 to start, but after 2 hours, I'm at about 42,000 miles on the car. So that eliminates D. Question 4 is meant to confuse you. So I went through and read it again and realized that going through we have Edwin driving from basically X to Z, but we're going through city Y. So given all that information there, that if he's driving 261 miles and it took 4.5 hours, his speed was 58 miles per hour. Just got that by dividing. So then he continued on for another 145 miles. So that means if he's going 145 miles at 58 miles per hour, he has another 2.5 hours to his trip. So X to Y was 4.5 hours. Y to Z was 2.5 hours. It gives me about 7 hours for that trip. So in question 4, they give us some information about the minutes that have passed since an airplane began its descent above and having the height above ground. So we can see that that height above ground is about 24,000 feet, but we're just going to abbreviate to the 24. And the slope, I found a pretty point right here. And so that slope was down 3 and right 4 on my graph. So my slope here, I can see it in my equation. So my equation would be 24 minus 3/4 x. Remember, x is being the minutes and y is being that height. So if I want to know how long does it start its descent when the airplane reaches a height of 3,000 feet, okay, 3,000 feet. Remember, I'm already in thousands. So when I use my equation, I'm going to let y equal 3 because I already took off the 1,000 portion of my 24 in my equation. So let y equal 3, and I can set up my equation. 3 equals 24 minus 3/4 x. And go through and solve that equation from there. And I'll find out that C at 28 minutes is my best answer. Okay, if you take a minute and look at this problem is actually pretty easy because we can see from our graph that he starts with 20 gallons of gas, right? We can see this on our equation. It's intercept form. I can eliminate C and D right off the start. I should be able to eliminate B. I mean, I went through and showed you my slope calculation to prove it to you, but I can eliminate B because it's a positive slope and I can clearly see my slope is negative. Another easy problem, right? Going through and looking at this, we have a graph of a line. What is the y-intercept of the line? Looking at this graph here, easy enough. That y-intercept is 5. Hopefully another easy point here when you look at this. I put in a fitted line and going through and think about, well, what can we eliminate? I can clearly see that I have a y-intercept of 0. Okay, so I eliminated A and C. I do not have a y-intercept -4. -4 would be somewhere down here, and I'm nowhere close to that. So now it's down to B and D, and what would be my best bet? A slope of roughly 3, round this guy up. If you think about it, going up 3 and right 1 gives me roughly the fitted line that I've put in. If I use this guy and think again, this is about 4/10. That means I would go up 4 and right 10. I would have a point over there, and I definitely don't have a fitted line going in that direction. D is your best answer. Quick review about this guy here, because this is a little review of your statistics from the past couple years. When we talk about range in data, we are talking about taking the large value minus that small value. So if we have a range of the weights of all the goats in a farm is 180, that means we have some very large animal minus a small animal equals 180. So think about what that means. The heaviest goat on the farm weighs 180 pounds, well, that would make sense too if I also have a goat that weighs 0 pounds. So that doesn't make sense. The information about exactly 50% of the goats has nothing to do with the range. So it looks like D is our best answer. And if we check and we look at it, there's a goat on the farm that weighs 180 pounds more than another goat on the farm. That is exactly what's going on here. That's your definition of a difference there. So D is your best answer. A pie chart. So we have information here about the number of cookies sold at the bakery each day. And I went through and I averaged those. After I went and read the rest of the problem here, we're talking about, how many more chocolate chip cookies than oatmeal cookies will be most likely be sold during one day next week. So I went through and I took the mean of those 7 numbers to try to get a rough idea of what happens in a daily type of effect. And you can see I got a mean of exactly 300. So then 40% of those sales are chocolate chips. So that means it's about 120 cookies. 15% of those are oatmeal cookies, which gives me about 45. And the difference between those two guys is 75 cookies. Another classic problem going through and figuring out a data set. We know she has 6 friends. Don't skip over that important piece of information there. And so I filled in and thought about my numbers here, because we have 3 friends who watch the most movies of the summer. So that's important to know that we're talking about these are the top 3 students. So I've got the top 3 numbers there in numerical order, and I have 3 numbers that I'm missing. So going through, I started with finding the median. I thought that important information was first, because I know that the median is the number in the middle. Well, if I have 6 numbers here, I have to find a median of 8. What number do I need in this spot? So that number plus 12, and then divided by 2 gives me an 8. The only number there that would work would be 4. So the 4 goes there. Then I knew the range needs to be 16. Remember, range is the highest number minus the lowest number. So 18 minus what would give me 16 gave me the answer of 2. So I was able to eliminate A and B right away. And then I'm down to C and D. Well, I can use my calculator to help me figure out what, I'm either down to 3 or 4. I know the mean needs to be 9. So I can use my calculator to say, well, if I put a 3 into this spot and I add them all up and divide by 6, does that give me the mean of 9? And the answer in that case was yes. I, of course, take a minute and check D, make sure D doesn't work, but it didn't. C is your best option. And last but not least, let's talk about probability. We have some information here about there being 60 total shirts inside of a box. And it's broken down into those numbers that you see there in that first sentence. Knowing that employee is going to randomly select 3 shirts from the box. So they're going to take a shirt from that box and put it on the store shelf, meaning they're not putting it back into the box. So what could be used to determine the probability that an employee selects 3 brown shirts? Well, that first choice, there's 20 brown. We're talking about picking brown shirts. And we're only going to do it 3. So you can see 3 fractions here. I've got 20 brown shirts in there out of the 60. So that's the chance I would get a brown shirt the first time. But now I'm down a shirt. And I'm assuming I've picked a brown one. So now there are 19 brown left out of a potential 59. And then for that third choice, I'm down another shirt, so it's 58. And again, assuming I picked a brown, now there's 18 left out of that 58. You don't have to go through and multiply them. They just want to know which expression is best, and that's why it's option B. Option A is showing me that basically 60 shirts, 60 shirts, 60 shirts, which doesn't happen. As I take a shirt out, I go down a shirt. C is basically, again, the same thing. And then D, it's assuming that I still have 20 brown shirts every single time, and I'm not picking a brown shirt. I'm picking a brown shirt those times. So B is our best answer.